Hello everyone and welcome to Legends. In today's video we are going to be going over a project which is an RFID attendance authentication system or attendance system or authentication system or authentication attendance system, whichever way you'd like to put it. But this is a system that enables you, mostly we are going to be going over the lecturer based setting. So it's going to be used in a university setting for those who have students that want to take attendance for their lecture. So this fits for final year projects for students or just as a really good project that you could implement in your surrounding or environment. So basically it's an authentication system using an RFID card scanner which allows you to determine who enters somewhere, at what time they enter, and you can also restrict access to the place using an RFID card or just take attendance of the students who enter a building using the same RFID cards. So we're going to be going over this project, how it works, the aim, the sequence of operation, the components that were used, and they're going to see the final testing of the project fully working. And it's going to be a framework project. What that means is that this project isn't packaged up like a fully built project, but it's actually functionally working, and you can use it to build on it and create your own project. So you can build on it and create your own projects with more advanced systems, a better front end. But in this project, we're only going to have a backend database that holds the information. So let's get into it. If you like our type of content, if you like the type of things I'm going to be posting and the type of content I'm putting out, please make sure to subscribe, drop a comment about future projects that you want to see me build, and let's generally check out all the other social media handles in the description: Instagram, Twitter, TikTok. We're going to be posting more frequently there because YouTube videos are full-blown videos, so you can get much more frequent updates on content there. And make sure to just share to other people and tech people, especially for those of you in Nigeria. This is going to show you that you can build these things in your own room, in your environment. These equipment are already available just for inspiration for those of you in the environment, or those of you in Nigeria rather. So let's get into it. So first of all, let's go over what an RFID card is. So RFID stands for radio frequency identification. Now, to go over everything about RFID would take a while, and it basically can be a separate video because the RFID cards around you would be like those who have gone to hotels, who you can see those white cards they give to you, they give you access to your rooms. You swipe them across your door handle that has a scanner there, and then you get access to your room. You also have RFID cards in your ATMs. When you tap them on top of ATMs that you slide into your ATM machine, scans. There's so many versions of RFID, which is radio frequency identification. But today we'll just be going over a basic set and module which you can buy and have around. So the list of the components in the project will be given up here, but just understand that your card has chip and can receive and transmit data. Basically, that's it. So just an RFID card consists of the card itself, a chip, a substrata, and an antenna. So it can both transmit and receive information, but it's more or less of a passive component because it doesn't have a battery in it, but it can receive and transmit data. It can respond to the scanner, so the scanning module. But let's get into the main crux of the project. So let's go over the operation sequence of the project. The project in itself is going to have this operation sequence. So first of all, you need to be able to scan the card. Next, you need to be able to identify if that card is a card that has been registered. So that's to prevent cards that are not registered to have any impact on your system. It's going to also have the ability to send that card's data to the internet, to a database. Then it's also going to be able to run whether there is power supply from the AC mains or not, which means that it's going to have a rechargeable battery system. And I think that covers it all. That pretty much covers it all. So all of these different components and parts, which are the major aims of the project, is what we're going to be going over in this video. Let's get into more details about how the project functions. So the components that we're using in this project include RFID cards, RFID card scanner, which comes as a pair or a set. You have an LCD to display whether your card was scanned or not. You have a Wi-Fi module that allows your Arduino, which is the heart of the brain rather of the system. So you have an Arduino, and then you have the Wi-Fi module, which allows you to communicate with the internet and the Firebase database. You have the Firebase database, which I just mentioned. You have a battery system, which would contain a charging and discharging module for the batteries, and you would have an adapter to supply 12 volts DC to those charging modules, but they would require a 5 volt supply, so you need a voltage regulator circuit to give 5 volt supply to those modules, and you would also need a lot of jumper cables, Vero boards or perf boards, soldering iron, and tape. A lot of tape. You could use a breadboard instead of a perf board, which is solderless breadboard, or you could just get solderless breadboard, instead of a perf board and use those instead. Well, these are generally the components that were used for this project. A lot of assembling and soldering would need to be done for your 12C, which you connect to your LCD. So that's another component, a 12C, which allows you to reduce the number of pins that you'll be using on your LCD by changing the communication to 12C. So that's one of the other components. So here is the full-blown operation of the project and how it works in its entirety. So I'm going to go over that stage by stage, step by step. So when I'm building projects, I use a bottom to top approach when building and a top to bottom approach to dissect the project. Just as I said, the sequence of operation from the top to the bottom, which would be what's the aim. So you start at the top with what's the aim of the project, and then it goes to the bottom as to the components that make up the different stages that allow you to achieve the aim at the top. So that's a way to dissect the project. And then when you're building, I build in modules. So you build one module, you test that module, build another module, you test that module, combine them to fit a certain criteria, and then you keep on ascending. So you see that structure being laid out in the description of how it functions. But that's by the way. But let's get into it. This is the operation of the RFID card authentication or attendance system. You have an RFID card which is issued to you by the owner of the system, so whether it's in your university classroom or not. So we're going to use the university, let's use the university classroom as the main criteria or structure for this testing. So we're assuming that you have a lecturer in the class who wants to take attendance. It's an attendance system. All of the students have an RFID card which holds their unique ID. So each card holds a unique ID. Now you have two options, either to immediately attach the unique ID to a unique ID in the database that the school already has, which would be your matric number. So for those of you in university, your matric number is a very essential code where all of your information is stored under. So that matric number is going to be attached to your unique ID, so that way you don't have to create a new system using the unique ID as a form of identification, but rather you can use the already established matric numbers and pair them to a unique ID, which would be unique on each and every RFID card. So this is how this is how the system functions. Again, you have the system, you would have your RFID scanning module, you would swipe your card by the module, and when you swipe your card by the module would read the unique ID on the card, transmit that to your Arduino is going to read that, and then it's going to compare it with the already established set of unique IDs that the Arduino has. In this case, we're not going to be using a lot of data. We just used about 10 cards, so the Arduino is able to hold up to that amount of information. When you're going to higher volumes, you need to change up the system a lot. But in this case, and it would be best to even use a wireless database rather than using a hard-coded one. But in this case, we hard-coded it into the Arduino code to check just these 10 cards. So if the card is not registered there, it's going to give a different response. But let's get back into it. So the card is scanned through the scanning module, and when the Arduino reads the code, the unique ID that is attached to the card, it checks that with I would call it a mini hard-coded database, which contains all of the unique IDs that are supposed to have access or are supposed to be registered. So if it's not amongst those, it prints to the LCD and displays failure. If it is and it's a registered card, it prints success. So if it can print either failure or success, and if there is no card being scanned, it prints no card detected. Now that no card detected works in the case of you having your card held up on the RFID scanning module for too long. After scanning and it says either success or failure, it switches back to no card detected until a fresh card or that card is removed and put back there. So that's the essence of the no card detected being printed on your LCD. So your LCD helps to display and helps you to see whether your card scanning was successful or not. Now that unique ID has to be sent to your database, and how do you achieve that? You achieve that by sending the unique ID to the Wi-Fi module. Now mind you, for those of you who haven't used the Wi-Fi module separate from an Arduino or haven't used a Wi-Fi enabled board, you have to learn how to use the Wi-Fi enabled board and you have to connect it to the database, but that's almost for another video. But in this video, how it was done is that this Arduino is supported on the Firebase database, which is the server we're going to be using. So it's Firebase real-time database, which you can create for free on Firebase, which is a Google created sub company, something like that. I don't know how to confirm. I'll put it up in the video. But yes, so your Firebase database is going to hold all of the information that you send to it. Now, we don't want to send, in this case, we don't want to send data to the Firebase database that isn't confirmed. So that therefore only the card that is scanned and says success, which is one that has been hard coded in our small mini database, will be sent. The information from that card would now be sent to our database, and then you as the teacher can then view the database and see who scanned, what card was scanned, who owns the card, and at what time. But we won't go into that much. As I said, this is a framework video. I don't know if I've said that already. It's a framework video, so you can build upon this project a better interface for the front end, a better back end interface. This one is just going to be a purely demonstrative project. So in this case, where you have your card scanned and this unique ID has been taken, now the ESP01 Wi-Fi module, which is the ESP01 Wi-Fi module, which is based on the ESP8266, is supported on Firebase database, but it has an old library, so you'd have difficulties using it. I would put the link in the description for how to use it and how I got how to use it. I had to alter the database even a bit, the settings of the database, not to get it to work, but it finally worked. So understand that your Wi-Fi module has it's like a separate microcontroller from your Arduino. So you use your Arduino to program your Wi-Fi module, then you program your Arduino and enable it to send data from your Arduino through the serial communication to the Wi-Fi module. So Arduino programs Wi-Fi module. Arduino gets its own program that allows it to communicate and send data through the serial communication to the Wi-Fi module. The Wi-Fi module then receives that data and, as per the codes, sends the received data to the database. That's how it's programmed. Now, as I said before, this project should be able to run whether there is power supply from the AC mains or not, and that means that it's going to have a rechargeable battery system. Now, let's keep it quick and short. Each of the batteries has their own charging module. Those charging modules are each supplied 5 volts from the same supply. So we have a 12-volt adapter which has 2 voltage regulator circuits that output 5 volts. Each of those voltage regulator circuits that output 5 volts charge an individual battery, and then the output of those batteries from the charging module are connected in series and then fed to the Arduino, and the Arduino supplies power to every single other thing on the schematic. Now you can actually supply power to your LCD, you can supply power to your ESP01 Wi-Fi module, you can supply power to your RFID card scanning module, all separate from your Arduino, and those would now drain from there instead of draining from your Arduino. But since everything is within the 5 volt and 3.3 volt range and should not be enduring any stress like an electric motor or a servo motor where you would want your power externally supplied and your control pin to your Arduino alone, this functionality works where you only supply to your Arduino and then let all the current drain come from your Arduino. So that is how the system functionally works. That is the explanation for everything for the system. So now we'll proceed to the testing videos, showing you how it works, showing you videos of it working, so you can see it's working as the card is being swiped. So you can see it's working as the card is being swiped and data is being uploaded to the database. I will be releasing the schematics for the project in the video, and in upcoming videos I'll be releasing more and a full documentation for it. So make sure to subscribe, make sure to like, make sure to share. Once we hit a couple, I don't know what number of followers, you guys tell me. Once we hit a high level of followers, then I'll start releasing the full documentation in the video descriptions with a link to a Google document, because these projects take a lot of time and work to make. Program them myself and everything, so it's like original stuff, even if it's fed off of other people's stuff. So I do feel indebted to them, and also we put their own resources so you can have those resources available. But at least before then, let's rack up some followers, rack up some rapport. Let's get the channel really moving forward, and I'll start dropping all of those details in the description. Well, I think that's it for this video. Thank you all for watching. As I said before, you can check the description for other platforms: Instagram, Twitter, TikTok, whichever one you're interested in. You can go there, you can send a DM there to me if you want any information and stuff like that. Make sure to subscribe, as I said before. Like, if you made it this far, really thank you. Thank you for those of you who are already subscribed. Actually, those the main supporters, the OGs for this channel, and hoping to grow the channel a lot more. So see you in the next one.